Okay, today we are working on 6.3, which is applying linear functions. And we need to be able to pull out the important information from word problems. So today does involve more of your complex word problems, which I know is your guys' favorite. So now important as we pull out important information here. We know currently right now there's 15 bottles of this vitamin in stock in the store. We know the manufacturer ships these in boxes of 20. Another important piece. We need to write a linear function, which if we go back to what is today about, applying these linear functions to real world situations. So we're trying to figure out something, an equation that relates the number of boxes to the total number of bottles in the store, and then eventually graph. So what do we know? We just said the total number of boxes on our shelf. So this is my little store here. The number of boxes of vitamins in this store is going to equal 15 that I currently have on my shelves, plus however many boxes I have in the back. And I need to times that by 20, because in each box there is 20 bottles. Okay, so X is going to stand for the number of boxes, Y is going to be the number of bottles. We're going to get an equation that looks like Y equals 15 plus 20 times X. Let's go back through and I'm going to explain again where I got this information. So Y here, let's go back one more step yet. What are we trying to find? I'm trying to find the actual, so what this word problem is asking me is how many bottles of a vitamin do I have in my store? So let's say I'm the owner of my store and I want to know at any given point how many bottles do I have of this vitamin in my store. So Y, my total here, is going to equal the number of bottles. And Y is going to equal 15 plus 20 times X. 15 comes from the 15 bottles that I currently have on the shelf. So if you walk through my doors, through my store, I currently right now have 15 bottles on the shelf. I need to add these 15 bottles to how many boxes I have. Now in each box that I have, there's 20 bottles inside that box. So if I had one box, I'd have 20 bottles plus the 15 on my shelf. So in one box, 20 times 1 is 20, plus my 15, I would have 35 bottles of this vitamin in my store. Now if I had two boxes, I would have my X equal to 20 times 2 would give me 40 plus 15, and I would have 55 bottles in my store. So the first part of this question said write a linear function that relates the number of boxes to the total number of vitamins in the store, which we just did. Now we need to graph. So if we graph this, I'm not sure if you can see, I need to move this over. If we graph what this is, you can see here Y equals 50 plus 20 times X. This is what we've been working on. We have typically the last couple days we worked with y equals mx plus b. Well, this is flipped around just a little bit. So what this really is saying, it's y, where should I put this? I'm running out of room. We'll go up here. Y equals 20x plus 15. So I just rearranged these two numbers here. Okay, we've got 20x plus 15. So when I go to graph this, my y-intercept is going to be, so if I go to graph this, my y-intercept is going to be at 15. Now, if I go, my slope is going to be rise over run. I'm going to rise 20 and run 1. So if I had 0 boxes, I would have y equals 15. 20 times 0 is 0. 0 plus 15 is 15. So y would equal 15, which makes sense. If I have no boxes in the back of my store, I would only have 15 of the bottles that are on the shelf to represent this. So now, if I had 1 box, I would plug in 1 in for x. 20 times 1 is 20, plus 15 is 35. So you can see here, this is drawn at about 35. Okay, now if I had 2 boxes, I would plug in 2 for my x. 2 times 20 is 40, plus 15 is 55, which is what we did. So let's take a look. Roughly 55. Perfect. 3 boxes. And instead of plugging 3 in, let's use this equation with what we know. Our slope is 20 over 1. So rise 20. So 50, 60, 70 over, this would bring me to 70 about here, over 1 brings me here. Rise 20 over 1, rise 20 over 1. And I create these points, which would be graphing the function. So you've taken your info, you have defined your variables, and created the graph. Your next problem here is students in 9th grade class drew the following graph to represent how much money would be in the class fund after selling sets of photos of their year activities. So my first question here says, what does the slope and y-intercept of the graph mean for the given situation? So first question, slope means what? And my y-intercept, which is b, means what for this here situation? So take a moment, pause the video, and figure out what this means. Alright, you should have found the slope is 15. So we rise 15 over 1, rise 15 over 1, rise 15 over 1. And what does that represent? The class charged $15 per sets of photos. Okay? So since this is showing of photos, that is what my rise and run is showing. I went up $15 per set. So $15 was my slope, so the class charged $15 per set of photos. My y-intercept is 25. Okay, so I'd write b equals 25. 15. And what is this saying? That means they had 25 bucks in their fund before selling the photos. Alright, next 2 questions here. If the graph had the same plot, but the y-intercept, so my b equaled 40, what would you say? Pause the video and write down what you think that this would mean. What would this represent then? If you wrote down that said that there was $40 in the class fund instead of 25, you were correct. Okay, and the last question, question C here. If the graph had a slope of 12.5, what would you conclude? Take a moment, pause the video. Okay, if you conclude that the student charged $12.50 per set of photos instead of that original 15, you would be right. Please go ahead and start the practice problems on the back. Once you're done with the practice problems, you can start working on the application problems for this section.